Welcome to Let's Make a Game Platformer, episode 27. In the last episode, I've added the transitions for when the level is loaded and unloaded for either reason of player death or player finishing the level. So this is how it looks. And in this episode, I'd like to add some more platformer features. In this episode, I'd like to concentrate on adding doors that slide up and down. So to start off with this, I'll take a look quick at the way we have done the rotation system, because we'll be using the similar feature where we're going to be moving something up and down. So before we had rotate component, and now we have to modify the location component of the entity. So we had rotate model on movement and constant model rotation. So let me maybe add to the logic a new component, new package, called transform. And in here, I'll add a new class, which is going to be a system for applying the transformations. Especially, I'll have different transformation ones for rotation, so model translate component. When translate is basically something that modifies the location. When you talk about 3D graphics, you have translate, you have rotate, and you have scale, and translate is about moving something. Okay, sorry, this shouldn't be common, this should be a system. Got distracted there for a second. Okay, so I'll register the system. And I'll have a couple of different ways of doing the translation here. Maybe first will be time-based translate component. Which will describe the translation extents, translation based on time. So it will move from point A to point B and loop. So maybe, how was it called in the constant model? Maybe I'll call the same constant model translate component. Okay, so it will be basically moving from point A to point B based on some timing here. So in here we have degrees per second. In here, instead, I will have long start time. Or maybe not start time, maybe, oh yeah, I'll have start time, I will have cycle time. So basically start time and how long its cycle takes. Which cycle is moving back and forth, so from some point to some other point, and we all now need to add distance. So X distance to travel, Y distance to travel, and Z distance to travel. Okay, let's go with this. So in here I will have to, because I have to do it in a game loop, so on every update I have to go through all the models that have this component, and I have to modify the location. Therefore, in here, I'll have lifecycle system, and I'll be using the entity index. Speed up the searching for these entities that have this component, and I'll add a implement method, initialize. And what I'm interested in is entities that have the constant model. component and those that have location component. Location component class. So the problem with having this is that I know what I want to move it by from some starting position, but I do not know the starting position. So I'll add a new component here, the same level that was the location component, which is going to be a base location. It's going to be for any entities that are moving in some fashion, and we want to know what's the starting point of the whatever movement it will have. Okay, so I'll add a component here, extends component, and we'll have X, Y, and Z. So our translate system has to also have the base location component. We'll utilize this as well. Okay, and now on the update system, I'll go through all the entities in the index. First, maybe on the index actually. So I'll get through all the entities that have these three components. I'll extract them. Translate entity, get component, location component, translate entity, component, base location component, and I'll have to use here a time manager to get current time in the game. Once only here at the beginning of the method. And now I have to figure out where in the cycle is this specific entity. So I subtract the start time, translate get start time, and call it base time modulo translate get cycle time. And so now I have to figure out whether I'm going up or down in the cycle. So this is when I'm in the cycle, and the half of the time of the cycle size maybe I'll change the cycle time to be integer because it doesn't have to be long. Half cycle length. If time in cycle is less than half cycle length, then time in cycle divided by, let me figure out, so half cycle length, then we are time in cycle divided by half cycle length, A, else time in cycle minus half cycle length divided by half cycle length So let's assume that the cycle length is 1 second, and so half of the cycle is half a second, and we are 0.3 seconds into the whole cycle. Therefore, the progress on from where we are now, from the base location to where we want to go to, should be 0.3 divided by 0.5. However, if the time in cycle exceeds the half cycle, so let's say that we are at 0.6 in a cycle, then we subtract the half of it and divide it by half cycle length, and then we know how far we are in the returning part. And to get the progress, we have to do 1 minus, because we are moving from the away point towards the base location. Okay, and now we have to apply the changes to the location. So we want to have base location get x plus a multiplied by distance x. So let's translate get distance x, and the same for y and z. Y and z. And translate entity. I have to save the changes. Okay, and this has to be in profiles gameplay only. Gameplay. Okay, so we have this. Let's maybe test it using one of the star prefabs. Let me just for the moment modify the star prefab and add this component to it. I will just roll it back in a moment. So we will have here start time, cycle time. Start time is going to be 0. Cycle time is going to be 1 second. So 1000 milliseconds, and distance y will be equal to 2. I'll leave x and z the same, and I have to also add base location component to it, which is going to be empty. And I have to add settings for it in a moment, because I'll be using them in a moment. Okay, so now the problem is that this has to somehow be populated with whatever level decides. I think the third level had the stars. No, second level had the stars. So it has to be populated with this. And the way we can do it is that in the level entity system, where the level is being created based on the stuff in the prefab here, we can check if the entity data, if the result has component base location. We want to make sure that we fill those out as well. So we will do the same as we did here for normal location component. We'll make it remember where it started off with, where it was started off the position of it. Okay, and then we'll save the changes. Okay, so let's try it, and in the second level the stars should now be moving up and down. So that first level and the second level, as you can see, the stars are moving now in a 1 second cycle, and yeah, so I can't catch them if I jump at the wrong time. Well, this is not something that we want to have anyway, but this was just for testing it. What I do want to use it for is having doors. So doors that open and close all the time. So let me revert the changes to the star prefab. And instead, I created here 2 images for the door. So let me now create a new object. It's gonna be, let me make a copy of star. Let's call it door, or cycle door, so that we know that it's on the cycle of moving back up and down. We don't want to not rotate them, and the model should be, let's create a new one, door model. And I'll not create cycle door because the same model, so this describes how it behaves, and this describes how it, the model itself, how it looks. We can have different models that, different doors that look the same, however behave differently. For example, one of them will open when you switch a lever and stuff like that. So let me add quickly the model door. I'll copy the star, door, it's gonna be cube, and z is gonna be 1. However, in the x direction, I want the door to be much smaller in the x direction, so let's say 0.2. And I want it to be 2 blocks high. And the front and the back is gonna be door front, and top and bottom, and sides, no, left and right, and right is gonna be door side, and top and bottom will be also door front. Okay, so now let me create a new level here. It's going to be a copy of the first level and add it as the last one. And quickly modify the level sequence to only have this one level, so I don't have to go through all the levels to see it. And in here, I want to do object coordinates. In here. Defining the level, and it's going to be cycle door, and position is going to be -1. Sorry, minus, somewhere in the middle, -3. -1, so just above the block, and 0. And now the model door, the cycle door has to have some additional components. So it's not collectible. Hitbox is model is going to be rendered -0.5 because I want to move it to the middle of the block. And hitbox is -0.5, 0, width 1, width 0.2. So this is going to be 0.4, I believe. And we don't need hitbox actually, because we're not going to be triggering something whenever it hit the door. Okay, and in here, I need these two components. So base location with empty values, because it's going to be filled out by the level loading itself. And I need the construct model translate component. I'm not interested in start time, I'm interested in cycle time. Let's say it's going to be 3 seconds, and I wanted to go up the distance y by 2 blocks. Okay, so let's see if that works. Okay, so we have door that move. However, character can still move through the door, so we have to make sure that we collide with these doors. So one more thing I want to do is just modify the level quickly to add some blocks above the door where the door will hide into. So I'll add them here. So -3, 1, 0. It's gonna be stone. -3, 2, 0, stone. Let's see. It's also to prevent player from actually jumping over the door once we make the door actually collide with the player. Okay, I moved them too far. That's wrong because it should be fine. Maybe translate. Yes, it should be half plus half, not minus half. And should be 0.4 because the door are width of 0.2. So let me run it again. Okay, so this is working, except the door are overlapping here. We can make them slightly thinner by modifying the model, saying that the z we're going to multiply by 0.9, and we'll move them by translate z 0.05. Okay, so we have door. They do not function as I said yet, but they will in a moment. So the way we do collision before for blocks was that we have collision obstacle component, which basically defines the size of the collision, or the rectangle size. So what we have to do here is find when it's used. At the moment, it's only working for platform, only for the platform blocks. You have to add a new platform, new collider that will be responding to the get collision point, and that will go through all the entities in the context and provide collision for it. So in the fix we have platform collider, and we have now model collider system, which will register and make sure it's run only in the gameplay mode, gameplay profile. I'll be using here entity index because I'll be iterating through all of them. Entity index manager. I have to create the index. And in the initialize method, I will do create the component. Okay, create the index on collision obstacle component and location component. Collision entities. And in the method that is responsible for get collision point, I'll go through all the entities that have these two components and do very similar stuff to the platform component. So I'll just copy this code for now. Except the platform doesn't have rectangle and sides. Okay, so rather than this, we'll have entity, collision entity, get component, collision obstacle, and location. This, of course, can be improved by, once again, having the quad map or octomap if you want to do in 3D location. And so I have to first check that the obstacle sides, okay, let's do it sides, if sides equals null. So I basically copy and modify the code here. So if sides equals null or contains direction platform sides event get direction. So I have this part already translated. I have to copy the contains direction method. Probably some refactoring will be needed to use the same code rather than have two separate copies of the same code. And now I have to create the rectangle. So what I need is the so it's gonna be location get x plus obstacle translate x. The same for y and for y, not for z. That's when we're only doing 2D. And in here we need width and height, and we have obstacle get width, obstacle get height. Maybe move this to one line. This is the rectangle, and if this rectangle, well, float here, and if this rectangle intersects, then we get rectangle get max x. And what's missing here? Nothing is missing. Okay, so what I have to do now, So what I have to do now is add this component collision obstacle to the door prefab. Sorry, to the door cycle door prefab. So in here we'll have collision component. So it will collide on all sides. So we don't need sides. We just need these four values. So we will have translate x. It's going to be the same as here, 0.4. Translate y. There is no translation. Width is going to be the same as in model. So we'll have 0.2. And height is going to be 2, because the door is 2 blocks high. Okay, and let's take a look. I have door, and it blocks me from passing through until I goes up. Excellent. So now we have the ability of adding entities into the game that, first of all, are moving in some fashion. Well, I'll expand on it a bit more later. And also, these entities can block the passage of the player or any other entities that has a collision component. What's the name? Colliding object component. So if we have enemies that have also this, and they do, I think the bug has the colliding object, it will not be able to pass through the door as well, and it will just turn back, because that's what we said. When you can go, turn back. Okay, that's it for this episode. Make sure to like it and subscribe to my channel. You can also follow me on Twitter, link is in the description. Thanks for watching. Bye.